All right, so now we're going to do, we just did the trig derivatives. Now we're going to do the exponential and logarithmic derivatives. And we already graphed this one when we were graphing the derivatives, but I think it's cool, so we're going to do it again. If you draw in some tangent lines, they're practically zero, but not quite for their slope. And then they get steeper and steeper and steeper and steeper. So this is going to start out really close to zero and then go up and up and up and up and up. So what do we notice about that? It's the same. All right, so I'm going to use this little bubble right here. The derivative of e to the x is e to the x. It's like the best one. Oh. All right, now that's for e to the x. Let's say you have a base that's not e. This doesn't come up hardly ever, but they could give you one. Like instead of e to the x, say it was 2 to the x or 5 to the x or 7 to the x. It's still going to be itself, but then you multiply on ln of a, like ln of whatever that base is. So it's like just one more thing to have to remember. All right, now this is your ln graph. If we start drawing in tangent lines, they are very, very steep, very, very big slopes. And then what happens to them? They get smaller. They won't ever quite be zero, but almost. So it's going to start out really, really big and then be almost zero, but not quite. This one's a little harder to identify because it's actually only half of the graph, but what is that the graph of? It's 1 over x, it's the rational graph. You just don't get this half of it because for logarithmic, the domain is only positive values. All right, so derivative, let's see, of ln of x is rational, 1 over x. And same thing, say you have a base that's not e. Again, it is not likely to come up, but just in case, I want to have shown it to you. Say you have log base 3 of x or log base 10 of x, like the common log. It's the same thing, it'll be 1 over x. And instead of multiplying on ln of a, you multiply on 1 over ln of a. So the exponential multiplies on ln of that base. The logarithmic, it's the reciprocal of that. Again, you're going to have to choose what you decide you want to memorize and what you don't, but I'm just showing it to you. Okay, so let's try these ones. So for number 11, derivative of 3e to the x is 3e to the x. It's great. It's fantastic. All right, and then what rule is number 12 going to be? All right, product rule. So it will be the first function times derivative of the second. Derivative of e to the x is e to the x. It looks like we didn't do anything. It's just it's itself. Plus the second function times derivative of the first. All right, this one's chain rule. So the exponential is the outside function, and then inside of that is the 4x squared. Let me zoom in. So it's going to be itself. And it's like, Ms. Cole, it looks like you just wrote down the problem. Sure did. That's all that is. And then you're going to chain on the derivative of 4x squared, which is 8x. All right, and then this one will be a quotient rule. You're going to start with the denominator, e to the 5x, times derivative of the numerator, which would be 2, minus the numerator times derivative of the denominator, which will be itself times what? Good. Derivative of 5x would be 5. There's a chain rule there. And then it's over the denominator squared. What I'm going to ask you to do, though, is just write it twice. I'll show you why. That's what squared means. writing it twice. You know how I told you don't cancel these out? No cancellation without factorization. You actually can cancel them for this one because you have an e to the 5x in all terms. Like if you were to factor it out, like you have it everywhere. So you can cancel it since you have an e to the 5x in all of them. So let's see what that would come out to be. This one's kind of worth it to simplify it because it's going to turn out okay. The numerator, this would be 2, and then we're going to distribute a -5 into the parentheses. So if you distribute a -5, that would be minus 10x minus 5. And so 2 minus 5, that would be -3 over e to the 5x. And then I threw one on here that had a base that's not e, just so you could see what that looks like. It's still going to be itself. So like basically just copy down the problem. And then chain rule, you have to chain on the derivative of the inside stuff, which would give us what? (2x), good. And then you just have to multiply on an ln of 7. So it's not hard, but it's just one more thing to write down. All right, and then here is the logarithmic ones. Derivative of ln of x is 1 over x. This is just going to be 4 over x because there's a 4 there. Like, don't overthink that. There's just a 4. See, these ones go pretty quick because there's not much to them. All right, and then this one's going to be a product rule. Start, again, these are going to get large horizontally, so start like kind of towards the edge of the paper. All right, it's going to be the first times derivative of the second, which will be 1 over x, plus the second times derivative of the first, which will be 6x squared. There is one thing I do want to simplify down there because I do think it is worth it. What's going to happen in this first term? Yeah, like 1x is going to cancel out. So it'll actually be 2x squared and then plus the rest of this. I think that does look nicer. Like if it's worth it, I'll simplify something down. It's just a lot of times it's not worth it at all. All right, this one's a chain rule. It's like ln got hungry and ate 5x squared minus 3x plus 8. I know the rule says 1 over x, but it's 1 over that stuff. It's like 1 over all of that. The guts of the problem stay the same. And then you chain on the derivative of that stuff. And I would just put it in the numerator instead of off to the side. So what's that going to be? Yeah, perfect. 10x minus 3. All right, this one is a quotient rule. So it will be the denominator times derivative of the numerator. Let me show you what this will look like off to the side. It's ln of 2x. That derivative would be 1 over that stuff, but then you'd have to chain on the derivative of 2x, which would be 2. So the 2's are going to cancel anyhow. So it's just going to be 1 over x minus the numerator times derivative of the denominator, derivative of sine, cosine, and then it's over the denominator squared. And then I threw one on here that's not ln. It's going to start out the same way. It's 1 over whatever you've got. So 1 over 10x squared. You're going to chain on the derivative of 10x squared. And I usually just put that right in the numerator. That'll be 20x. And then you have to multiply on 1 over ln of whatever the base was, which in this case is 3. Now I am going to simplify that down because again, if it's worth it, I do it. how is this going to reduce? Because we get some stuff that cancels here. Yeah, good. It'll just be 2 over x, and then that ln of 3 is also in the denominator. Again, if it's worth it, I do it. It's just a lot of these, it's like is this worth it? No. But if it is, I'll simplify it down. On the test, I think there's 2, I was just looking at it this morning. There's 2 problems that I want you to simplify, and I wrote next to them exactly what I wanted you to do. Get rid of the negative exponent or like whatever it was, and the rest of them you can just leave alone. All right, this one's got 3 links in the chain. What's the most outside? Yeah, the exponent. So we're going to bring the 3 down. It'll drop to a 2. Everything else stays. And then you have to chain on the derivative of cotangent. It's a co, so it'll be negative. Who's cotangent's buddy? Or think of your PIST thing that you guys were saying. Good. It'll be negative cosecant squared of e to the x. Again, remember the inside stuff stays. And then derivative of e to the x is e to the x. Like on the test, I would want you to just leave it like that. In fact, it's easier for me to grade if you leave it like that, because I can check each link in your chain. Like it's really easy for me to grade. I can just see it's all there. Same with this one. We're going to start with the most outside function, which is secant. So think about secant's buddy, or think about your PIST thing that you were bringing up before. What is your derivative of secant? Secant tangent. And again, remember it's of that stuff. All right, so we're done with the secant. Now we're on ln. Derivative of ln, that would be 1 over 4x. The same thing's going to happen here. It would be 1 over 4x. And then the last link in your chain would be the derivative of 4x, which would be 4. And they're going to cancel. So it would just be 1 over x. Or I guess you could just put this entire thing over x. However you wanted to write that. That's like your best. All right, I always throw one of these on here just to bring up the logarithm properties from last year. Every single year, everyone just stares at me like we never learned that. I taught all of you in pre-calc, though, and I know I taught you this because it happened before we were out. It's fine if you don't remember it. I'm like not offended at all, but I'm gonna just bring it up. All right, your log properties. Everything on the top is gonna get added. Everything in the denominator is gonna get subtracted. And you're allowed to take that exponent and put it out front. Does that ring any bells? Like you can take that exponent and put it in front. So for the x squared, that would be 2 ln of x. And then we're going to put plus, anything in the numerator is positive, denominator is negative. It comes from your exponent rules. Now for a square root, what's the exponent on a square root? 1/2. And you put that out front. So it'll be 1/2 ln of x minus 1. Minus, and then for the denominator, ln 3x plus 4. If you don't remember it, it's fine. But why on earth did we do that? Because now we can take the derivatives of these 3 separate terms. Instead of this, oh my gosh, that would be a chain rule with a quotient rule, a product rule, and then another chain rule inside of it. Like any takers? No. Okay. Okay, you can do that. We'll do this. We'll see who gets there first. So if you write it as 3 separate things, then you break it into bite-sized pieces, essentially. So now we can do the derivative of each of these separately. So derivative of 2 ln of x, that'll just be 2 over x plus. All right, we've got that 1/2, so we have that 2 in the denominator. This would be 1 over x minus 1. Now there would be a chain rule there, but the derivative of the inside stuff is 1, so it happened, but like you're not going to write anything. And then minus, and then this would be 1 over 3x plus 4, and then you would chain on the derivative of 3x plus 4, which is 3, and I would just put it in the numerator. So if you make it 3 separate terms, then that makes that a little bit easier. It's a lot less scary. All right, last one. Write the equation. You need a point and you need a slope. And our point of tangent C is e squared. So to get the y value, you're going to plug in e squared. Okay, e squared cubed. That would be e to the 6th. And then you would have ln of e squared. Ln and e cancel out, so you would just have 2e to the 6th. All right, slope comes from derivative. It's a product rule. So product rule says it will be the first times derivative of the second plus the second times derivative of the first. So what's going to happen with that first term there? Because that is going to reduce a little bit. That'll just be x squared. Okay, so we're plugging in e squared. So for this first part, that would be e squared squared. So e to the 4th, good. And then over here, we're going to have ln of e squared. And then 3e squared squared will be e to the 4th. So again, ln and e cancel. So this part's just 2 times 3 will be 6. So we have e to the 4th plus 6e to the 4th. Did you all follow me there, or do you want me to take you through it again? It was a lot. Because you can take the 2 and put it out front as the coefficient. You're just multiplying it on. So it's just a 2. It's not in the power anymore. Because this became 1. So it's really, if you bring this down out front, it's 2 times 1. That it throws everybody off. Because it's like, isn't that in the exponent? It's like, yeah, but you're allowed to put it out front. So. All right, so 1e to the 4th plus 6e to the 4th, 7e to the 4th. Don't forget to actually answer the question, because this happens. People get all excited. They're like, oh my gosh, I did all that work. I'm finished. Make sure you actually write the equation. It'll be y minus 2e to the 6th equals your slope, and then parenthesis x minus e squared. I realized that that looks like gobbledygook, and it's like we tried to jam every letter of the alphabet into that. But please remember that e is a value. E is approximately how much? 2.7-ish. Like if you remember it's 2 point something, I'm happy. Oh, we're going to do Euler's method later this year. Hold on to that. But this is a number. It's some kind of decimal. This is a number, and this is a number. It's like they're all just numbers.